All right. Let's see. All right. So for our second lecture, we're going to be looking at chapter 3.2. We're actually going to divide this one into two parts to keep the videos a little bit shorter. Sorry for yesterday. I know that was a little bit ridiculously long. I didn't realize how long it was going as I was recording it. I'll try to keep them shorter in the future. But this one is all about solving quadratic equations. Specifically today, we're going to go over factoring and completing the square, as well as a couple of other little things that are attached within the chapter. And then tomorrow we'll probably look at quadratic formula and then some like word problems. But first things first, let's get into solving quadratic equations by factoring. Now, you've definitely done this before, probably in Algebra 2. It's something that you probably haven't seen for a while or haven't practiced for a while, though. It's not necessarily the most fun thing. Some people really enjoy it, though. Factoring in general involves a lot of guess and check. But yeah, we'll go over how to do it really quick. So first of all, recall that the general formula for a quadratic function is f of x equals ax squared plus bx plus c. When we are solving by factoring, we want to rewrite our equation in the form of kx plus j times hx plus g. This kind of looks gross. You might not understand what exactly we're talking about here. It'll make more sense when we get to examples. But in this, using this notation, kh equals a, gj equals c, and kg plus jh equals b. And really all that's talking about is when you multiply these out, right, your x squared value is going to be led by whatever k times h is. So a has to be equal to k times h, because those are the values when multiplied will give you an x squared. G times j, these are your two integers, so they're going to multiply to form an integer. I guess they could be fractions. These are your two numbers without an x attached, so they're going to multiply to form a number without an x attached, which is your c. So that's g times j. And then kg plus jh, you'll have kx times g, which will give you some x value, and then j times hx, which will also give you something x. When you add those together, those should equal b. So this is actually called the systems of equations approach. So basically you could set up all these different equations and then solve all of these different constants. Each of these should just be a constant. They're not anything special. There's not like any, since we do use k and h in vertex form, that's not what this is talking about at all. These are just different constants, so it could be any number, whatever. But you could solve it with systems equations. That almost always takes more time. And honestly, if you're at that point, you might as well use the quadratic formula. It's just going to take a lot of time to solve that way. So don't do that. After we've gotten it written as this, though, we simply set each one equal to 0 and solve for x. And that's because of the idea of the zero product principle. So if this is equal to 0, this can be equal to whatever value. It really doesn't matter. But 0 times this will always equal 0, and then the same is true in the other direction. So if we have this equal to whatever, it doesn't matter as long as this is 0. We'll still get 0. Okay, let's look at some examples, hopefully clear that up a little bit. So for our first factoring example, let's start with the equation x squared minus 2x plus 1. Now, if we factor this, it's just 1 times 1. That's the only thing that we can have. So we have a is 1, which means both of our parentheses are going to start with just a plain x. If there was a number in front of the x, if like a was 2, we'd have to include a 2 in between one of these. And we'll talk about that more in the future examples. And then we know that whatever our values on the other side are have to multiply to equal 1. So we're going to have 1 and 1 because those are the only things. Now, since this one is positive, that means our ones can be both positive or both negative. They cannot be one positive and one negative. That's because if this one's positive and this one's positive, they'll multiply to form a positive. If this one's negative, they'll multiply to form a positive. And if this one's negative and this one's positive, or vice versa, they'll multiply to form a negative. We need them to be positive, so we got to pick either one or the other. I'm going to pick negative in part because I already know the answer, but also because we've got a minus here, and that's almost always going to mean that you're going to use negative numbers. So in this case, we have x minus 1 times x minus 1. In case we want to check to make sure that our factoring is correct, we can multiply this back out. We can FOIL it. So first we'll have x times x, which is x squared, Outside, we have x times -1, it's minus 1x. Insides, we have -1 times x, that's also minus 1x. And then last, we have -1 times -1, it's positive 1. Simplify this, x squared minus 2x plus 1 equals 0. So we know that that is correct. That's our original equation. So now we set this equal to 0. To solve these, we'd normally do each one, but since they're the same, we just need to do one of them. So x minus 1 equals 0. That means that x equals 1. And that is the solution to this problem. We should get x equals 1. You can also plug it back in and check at the end if you want to. So 1 squared is 1, minus 2 times 1, that's -1, and then plus 1 is 0. Second example, let's try 2x squared plus 2x minus 11 equals 1. First things first, we want to set our equation equal to 0. So first thing I want to do is subtract 1 from both sides. So now we have 2x squared plus 2x minus 12 equals 0. That's the first thing. Next up, we want to make our parentheses. So since we have a 2 in front of our x, one of these needs to have a 2 in front of it. The other one is just a normal x. Then for our second values, we're going to need to use factors of 12. So 12 can either be 1 times 12, it can be 3 times 4, or it can be 2 times 6. Because this is negative, one of them needs to be positive, one of them needs to be negative. So in our case, I think what I'm going to do is try 6 and 2. We're going to use -6. We're going to use +2. You can start with any one of them if you want to do guess and check. Eventually, the more practice you get with this, usually the better you get at it, the faster you are at factoring. And in general, sometimes it's really easy to see them. Sometimes it's really hard. Sometimes you have to guess and check multiple times. But that is almost always faster than doing it by the systems of equations method, which, by the way, your book doesn't even go over because it's just so much extra work and it's really not worth doing. Anyway, so if we try this, we FOIL this out, we'd get 2x squared minus 6x plus 4x minus 12. So in this case, when I add these together, I get 2x squared minus 2x minus 12, and that's close to what I want, but I've got the symbols mixed up. So what I'm going to do is just switch these, minus, make this a plus. Now I have plus 6x, and then I have minus 4x. When I do those out, I get the correct one. So that's one of the ways you can just switch things with guessing and checking. If you get things wrong, a lot of the times you're going to be close, so you can just replace one thing. So anyway, now that we have our two factors, we're going to set each one equal to 0. So we have 2x plus 6 equals 0. We have x, this is a minus. It's a really bad minus. We have x minus 2 equals 0. This one's super easy to solve. Add 2 to both sides. We get x equals 2. This one, we subtract 6. Then we have 2x equals -6. Divide by 2. And we get x equals -3. So our answer should be -3, x equals -3, and 2. Sometimes, honestly, it's better to write it as and, just because if you write it with a comma in between them, a lot of times people get mixed up and think maybe you're talking about a point on a graph or something like that. But our answers are -3 and 2. And that is, in fact, what the answers to this one are. All right, the last factoring example, this one might not even look like a quadratic formula or equation the first time you look at it. But with a little bit of simplification, we can very quickly see that it is 1. So if we subtract t and we subtract 1 from both sides, we'll get 12t squared minus t minus 1 equals 0. Now, to factor this one, we once again need to choose between the different things that multiply to get 12. So we can do 1 times 12, we can do 3 times 4, we can do 2 times 6. And then our other values are going to have to be 1. And since this is negative this time, we need 1 positive and 1 negative. So these ones are really easy. We can do -1, we can do +1. Something x and something x. We need to figure out what these values are. Now, there are a couple different ways we could try this. So we could just start plugging in numbers. You could try, like, let's say 6 and 2. And then if you factor that out, you get 12x. Oh, I guess these are t's, huh? Sorry, t. The variable doesn't really matter, but I suppose I should be consistent. So we'd have 12t squared minus 2t plus 6t minus 1. That gives us plus 4t. That's not what we need, so we know that that one's not right. So we can try some different ones. And let's say we could try, I guess if we really wanted to, we could try 12 and 1. This should be pretty obvious that it's not going to work. We'll get 12t squared again. This time we'll get plus 12t and then minus 1t and then minus 1. When we solve that out, we get plus 11t. That is definitely not what we want. So that one is also wrong. This time I'll actually do the correct answer. So then we could try, let's say, 3 and 4. Here we would have 3t times positive 1. That's, so let's do this one first, I guess, 12t squared. Then 3t times positive 1, that's plus 3t. Minus 1 times 4t, that's minus 4t. And sounds like 40. And then minus 1 times positive 1, that's minus 1. We have plus 3t minus 4t, that's minus t. 12t squared minus t minus 1. So this one is, in fact, our correct factoring. So now we want to set each of these equal to 0. So we have 3t minus 1 equals 0. And we have 4t plus 1 equals 0. Add 1 to both sides. Get 3t equals 1. Divide both sides by 3. T equals 1/3. And then on this one, we subtract 1 from both sides. We get 4t equals negative 1. T equals negative 1/4. So our answer should be t equals negative 1/4 and positive 1/3. And in fact, our answers are 1/3 and negative 1/4. Sorry, that's kind of in the way. All right. So now that we've talked a little bit about factoring and how to solve quadratic equations for the zeros, let's talk about what we can actually determine just based on the formula of a quadratic equation. So we've already talked about parabolas, how the graphs, what the graphs look like. Hopefully you already know that the positive a value tells you whether it opens up, or the positive a value tells you that it opens up. A negative value tells you that it opens down. Opens up versus opens down. That's like sideways, but whatever, you get the point. We've already talked about calculating the vertex. So this is the x value of the vertex, h equals negative b over 2a. And then you can plug that in to get the y value of the vertex. The y-intercept is equal to c when we have an equation written in standard notation. So an ax squared plus bx plus c. The y-intercept is equal to c, and that's because the y-intercept exists where x equals 0. 0 squared is 0 times a is 0, plus b times 0, which is also 0, plus c. So you're just left with c. So c is always the y-intercept when we're written in standard notation. If it's written in vertex form, that's not the same because you don't have c in there. The solutions to a quadratic equation set to 0 are the x-intercept. So what we were just solving for when we have a quadratic equation, 3 equals 0. Whenever we solve this, whatever values we get for x, those are x-intercepts. And one thing you'll notice is that technically a quadratic equation doesn't have to have any answers if you have it set like this. And that's because you can have a parabola in theory that exists like down here where it doesn't have any x-intercepts. Now, they should always have a y-intercept. If you don't see one, so if you just see x, like let's say here, let's say you saw x squared plus 2x. And that was your quadratic equation. It's just 0. It hits at the origin. That's because you can think of c as a 0. When you add 0, you don't do anything. So it always has a y-intercept. It doesn't necessarily always have x-intercepts. And it can also only have one. And that's if the vertex is on the x-axis. But we'll talk about that, I think, want to say that's tomorrow, but we'll see. It might be later today. I think it's tomorrow. Next thing we want to talk about is the square root property. This sounds all fancy and stuff, but it's actually a lot easier than solving normal quadratic equations. So any quadratic equation in which b equals 0, and remember we're talking about an ax squared plus bx plus c, can be rewritten in the form x squared equals k. So what we're talking about here is, let's say b equals 0, let's say a equals 3, and let's say c equals 12. When we write this out, we're going to have 3x squared plus 0x plus 12. We can get rid of this because we know it's 0, so we have 3x squared plus 12. And then if we want to write that equal to, or in this form, we can subtract the 12 from both sides. So let's say this is equal to 0 to start. We have 3x squared then equals negative 12, and then we can divide both sides by 3. So all we're left with is x squared equals negative 4 in this case. So we can rewrite any of those equations. As long as b is equal to 0, you can rewrite it as x squared equals k. If k is not negative, the solutions to the equation are given by x equals plus or minus the square root of k. You probably already know that, right? Like if I take the square root of both sides, I've solved for x. And because it's a square root of k, it can be a positive or a negative number, right? If I have 49, the square root of 49, usually if you see square root of 49, you're just going to write 7. But realistically, it is either 7 or negative 7, right? Because if you have negative 7 times itself, negative 7 times negative 7 is also 49. So this is kind of just making that more literal. So in this case, whoops, sorry. It says, let's try it with x squared plus 4 equals 20. So first thing we got to do is we need to set this equal to x squared equals k. We need to get it into this form. To do that, it's really simple in this one. We just subtract 4 from both sides. We get x squared equals 16. And yes, I made this example work really nicely. So now we take the square root of both sides. Square root of x squared, square root of 16. Square root of x squared is, of course, x. And then the square root of 16 is either plus or minus 4. You could also just write it out as x equals 4 or negative 4. It doesn't really matter. I don't really care either way. And if you want to, you can plug those in and check it. 4 squared is 16 plus 4 is 20. Negative 4 times negative 4, that's also positive 16 plus 4 is 20. So yeah, this stuff is usually pretty easy. But we can use it in equations like this that are going to be significantly more useful. So this is a problem that says the height of a metal ball dropped from a height of 100 feet can be modeled by the equation h of t equals 100 minus 16t squared, where t is the time in seconds. We want to determine how long it takes the ball to hit the ground. So this is actually some basic physics stuff. 16 is equal to 1/2 the acceleration of gravity, in case anybody cares, in feet per second. It is rounded. I don't really like that, but not really the point. So basically, if we want to solve this, we start with 0 equals 100 minus 16t squared. We subtract 100 from both sides. It would also, you could also just subtract the 16, or add the 16t squared. Either way, you're going to end up with a positive number when you get to the end. But now we have negative 100 equals negative 16t squared. We divide by negative 16. Now, you might be tempted to simplify this right now. You could divide both by 4 right off the bat, but it's actually going to be more helpful to leave it like this. So obviously we cancel the negatives. We have t squared equals 100 over 16. Now, the reason I said it's easier to keep it like this is that when we take the square root of both sides, both of these happen to be perfect squares. So if we do this, we get t equals, this is the same as square root of 100 over the square root of 16, which of course, now in this case, you do have you have multiple square roots, so you can have, plus or minus 10, plus or minus 4, but when you divide them out, they can only be positive or negative. So this is equal to 10 over 4, and it can be plus or minus. So our answer is t equals plus or minus, that's correct, plus or minus 10/4 or 2.5. However, let's go back to our actual problem. So we're talking about the height of a metal ball being dropped from a height of 100 feet. We're trying to figure out how long it takes to hit the ground. You can't have it take negative time, right? It doesn't work that way. We can only have positive. So our answer in this case is t equals 2.5 seconds. And that's something you always want to check when you're doing real world problems, real world calculations, is whether or not negative numbers make any sense. A lot of times they don't. So in this case, you can't have a negative time from the ball being dropped because it was still being held by somebody and they could have been doing whatever. All right. The next thing that we want to talk about in this chapter, I'm not 100% sure why this is placed here instead of in either the last chapter or in chapter 1. But it's just determining whether or not equations represent functions. And since it is in this chapter, I figured we'd go over it. But I'm not 100% sure that this is something I'm going to be testing you guys on, to be honest. It doesn't feel like it belongs in this chapter. Although it does go along with, I think, a little bit of what's done in 3.4. So maybe that's why they're trying to do it here. But anyway, the idea behind this is that when we get equations with multiple different variables, so like if we have x and y in our actual equation, we may want to determine whether or not the equations represent functions. So whether or not the output variable is a function of the input. The thing to remember with these is that if a y value, I'm kind of skipping ahead a little bit, but a function is defined as an equation that has only one y value for each x value. So what we need to do is solve these for y, and then we need to determine whether or not they're going to have more than one answer. And this can be done, it's a little bit complicated. They have some pretty difficult examples on purpose, but I'm going to walk through them right here. So let's start with the first one. We have x squared plus y minus 1 squared equals 4. At the end, I'm going to tell you what this is actually a graph of, but if I told you that now, it would give away the answer. So first thing we want to do is we want to try to solve for y. So we're going to subtract our x squared from both sides. We get y minus 1 squared equals 4 minus x squared. Next thing we want to do is we want to take the square root of both sides because we have to get rid of this whole squared. Since these are in parentheses, we have to do these last when we're doing inverse operations. So what we will get is y minus 1 equals the square root of 4 minus x squared. Now, it might be tempting to write this as 2 minus x, but that would be inaccurate. Because this is you're taking the square root of the whole side, you can't do them individually like that. And I could show you an example of why if you want, but it really doesn't matter. The point is, since these are both under the same square root, we can't simplify it at all. If it was a fraction, we could, but in this case, we can't. So then we want to add 1 to both sides. And remember that the square root of this can be plus or minus. So now we have y equals plus or minus the square root of 4 minus x squared. There should be a 1. So since y equals 1 plus or minus the square root of 4 minus x squared, there are two possible answers, right? We could have y equals 1 plus the square root of 4 minus x squared, or we could have y equals 1 minus the square root of 4 minus x squared. These are two different answers, and if you have two different y values for the same x, that means that you do not have a function. So this is not a function. So yeah, since there are two possible answers for this, y is not a function. One of the other ways that you could do this is you could actually graph this, which is kind of difficult to do. But if you do it, you would find that this is a circle. And of course, circles do not pass the vertical line test, so they are not functions. Let's try this one. We've got 2y equals x plus y over 2. First step, we want to multiply both sides by 2. Get rid of that. So now we have 4y equals x plus y. This one's really easy. We subtract y from both sides. We get 3y equals x, or y equals x over 3. This is a linear equation. It's equivalent to y equals 1/3 x. These are the same thing. And that, of course, is a linear equation or a linear function. So we know that this is, in fact, a function. Okay. That's really all there is about that one. Like I said, I'm not 100% sure why it's here, but I thought I'd throw it in just to make sure if it comes into play in any of your homework questions, you'll know how to do it. The last thing we're going to talk about today is completing the square. So completing the square is another way of solving quadratic equations. You've probably done this before as well. In fact, you've definitely done this before as well. I always found this one a little bit more confusing in school, so hopefully we can clear it up. We're going to go through first all of the steps kind of in order, and then we'll talk about how to solve them with some examples. So the first thing you want to do is rewrite your equation as x squared plus kx equals d. The reason we're using k and d here is because we don't want to get confused with our ax squared plus bx plus c. So we'll just stick with these new variables. Again, this has nothing to do with vertex form, so ignore or don't think that that k has anything to do with the vertex. So we have x squared plus kx plus d. Then we want to add k over 2 squared to both sides. Again, I am showing you this so that you can write these steps down if you want them. It's going to make more sense when we see an example. Next, we want to factor the perfect square. And what this actually will mean is that we're going to have the same number that's multiplied by itself twice. And then we take the square root of both sides, and then we solve for x. So let's look at an example. We have x squared minus 8x plus 9 equals 0. So the first thing we want to do is rewrite this as x squared minus kx, so in this case 8x, equals d, which in this case is going to be -9. We subtracted 9 from both sides. -9, -9. So first things first, we rewrote this. Now we want to add k over 2 squared to both sides. K is -8 in this case, -8 over 2. This is equal to -4. That squared is equal to 16. So we want to add 16 to both sides of this. So now we have x squared minus 8x plus 16. We're going to add 16 to this side. And when we do that, we will get equals 7. Okay. Next, what we want to do is factor this perfect square. And the reason that they call it a perfect square is because it is x minus 4 times x minus 4. The point of the perfect squares is that your k over 2 value is equal to whatever this is going to be, right? So if, let's say, for some reason k was 6, I would have 6 over 2 squared that I would add to both sides. That's 9. When I factored it, I would get x plus 3 for both of them. And that's just by virtue of k over 2 being what multiplies or what adds together to get this b value. So this we have set equal to 7. Then what we want to do, since this is x minus 4 squared equals 7, we want to take the square root of this, square root of this. So now we have x minus 4 equals plus or minus the square root of 7. Then we add 4 to both sides. So x is equal to 4 plus the square root of 7, or x is equal to 4 minus the square root of 7. And these are our answers for this one. So this, as you can see, is an irrational number, right? The square root of 7 is somewhere in between 2 and 3. But it's some non-repeating infinite decimal that would be a pain to write out. So we couldn't factor this normally. If we tried to factor this one normally, you could try all the different things. I promise it won't work. Feel free to give it a shot if you really want to. But you can't factor it without using these two numbers as your factors, and you're not going to find those by guess and check. So completing the square is the easier way to do these ones. That's really in the way, but it does say 4 plus or minus the square root of 7. And you can write it out like this, 4 plus square root of 7 and 4 minus square root of 7, or you can just do plus or minus when you're doing completing the squares. They're the same thing. Okay, let's look at a second example. We've got 2x squared minus 8x equals 7. So this one's close, but we want to divide both sides by 2 before we start, because again, we want that x squared plus kx equals d. So in this case, we divide both sides by 2, we're left with x squared minus 4x equals 7 over 2. So now what we want to do is we want to take our negative 4, which is our k. Remember, it's k over 2 squared divided by 2 squared. That's for negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we want to add 4 to both sides. So now we are left with x squared minus 4x plus 4 equals, I'm going to go ahead and leave this as an improper fraction. 4 as something divided into halves is 8 over 2. So we're going to add 8 over 2 to that, so we'll have 15 over 2. I know it's kind of a wonky step, but it'll make sense when we factor this. So if we factor it, of course, it's going to be x minus 2 squared. If we multiply this out, we'd get x squared minus 2x plus 4 minus 2x and flies to minus 4x. So there equals 15 over 2. Next step is, again, take the square root of both sides. So we have x minus 2 equals plus or minus the square root 15 over 2. And then we can simplify this by adding 2 to both sides. I'm probably going to be in the way of the actual answer again. X equals 2 plus or minus the square root of 15 over 2. And that'll be our answer to that. So we end up with x equals 2 plus or minus the square root of 15 over 2. Okay. That's the last thing that I wanted to talk about. We can go over more completing the square examples either today, for those of you watching it, if you actually watch it today, Thursday or Monday, or Tuesday next week, whenever really. It's easy, probably easiest when you're in person, but we can go over any of these things if you want to see more examples. But hopefully that at least is good enough to get you started on your homework assignment, which should be assignment 14 for tonight. And yeah, that should be it for this one. So I will see you guys later.